As you will already know if you've reviewed the other webbications on the Synergy.de.NET Assembly API, the GENNET utility examines a .NET assembly and generates Synergy wrapper classes that expose, via the .NET Assembly API, the types found within that assembly. GENNET also generates any types from any dependent assemblies which may be necessary for the operation of the classes in the assemblies being processed. If you're using GENNET to generate wrappers for custom assemblies that you've created in Visual Studio, containing specific classes such as forms that you wish to use in your Synergy applications, then this approach works pretty well. However, if you want to directly drive classes, say from the .NET framework, and use GENNET to generate Synergy wrappers for some of the assemblies in the framework, the amount of code that gets generated for all of the classes in a framework assembly and the classes that may be required from other dependent assemblies can be absolutely enormous. For example, if you generate using GENNET wrappers for one .NET framework assembly, system.windows.forms, around 80 megabytes of source code is generated, and you don't even want to know how big the resulting object libraries and ELBs are. Trust me, it's not a good approach. So, to help address this problem, Synergex have introduced a new GENNET feature, GENNET-S. This is currently an experimental feature in Synergy DE 915B on Windows. Experimental features are not documented in the Synergy documentation, but are discussed in the product's release notes. What GENNET-S does is allow you to specify the input to GENNET in a different way. Normally, you would specify one or more .NET assemblies as the input to GENNET, and wrapper classes will be generated for all the types in those assemblies and all required types from other assemblies. With the -S option, the input file to GENNET is one or more XML files, and those XML files not only specify the assemblies to be processed, but also specify the specific classes from within those assemblies which are to be processed. GENNET will still process dependent classes, but only for the specific classes that you've stated that you need to use in your applications. This approach allows you to specify specific target classes that you find you need in your applications, and results in compact amounts of code which are easily used at runtime. Let's take a look at an example. So here we can see a Synergy Workbench development environment. If you've already reviewed the hosting a Windows form in Synergy Applications webbication, you'll be familiar with this kind of development environment. I have two projects here. My first project that I want to look at is called GENNET Examples, and in this project you'll see that I have two test programs. My first test program is a graph viewer control, and if I simply run the demonstration, you'll see that it presents a very simple Synergy user interface and allows me to specify which graph I wish to view. When I pick one of the graphs, it goes off and uses the .NET Assembly API with some GENNET generated wrapper classes to present a .NET graph control. This is very similar to the example that was used in the hosting a Windows form in a Synergy application webbication session. Let's briefly take a look at the code and see how this application is implemented. The mainline program, if we go right to the top of the code here, called Graph Viewer, is really just presenting the simple menu. It's giving me two options, and depending on which option is picked, it takes me to one of these internal subroutines, sales targets or consultant performance. And if we look at sales targets, similar to the previous example, it's simply setting up arrays of data to be displayed. And the difference is it's calling this generic view graph routine. So view graph is a generic routine that you can pass a title, a legend, and series of labels and data, and it will just simply display that information. So that's where all the .NET Assembly API stuff happens. Let's take a look at that routine, and you'll see that we have the parameters defined to allow us to pass that information in. We also have code that drives the .NET assembly, or the .NET object, excuse me, or class. So we're using the bar chart class. This is a Windows form that we custom designed in Visual Studio to do the specific job that we wanted. So this example again is very similar to the previous example in the other webbication. Let's look at this other example, Report Viewer, because it's quite different. What this example does, if we run the program, again, there's a mainline program that presents a simple set of menu choices. And when we pick a menu choice, what's happening with this example is it's displaying a Windows form, and within that Windows form is a Microsoft SQL Services report viewer control, and we're displaying a SQL reporting services report in this pop-up form from our Synergy application. That's rather irrelevant in the point that I'm trying to make right now. What's important is the way that this demonstration is implemented. And if we look at the code, you'll see that it's quite different from the previous example. So again, the mainline program report viewer pretty much just displays a simple menu, allows the user to pick a choice, and depending on which choice is picked, it calls a generic view report routine and specifies the path to a report on the SQL reporting services system. What's different is when we look inside the view report routine. So let's go and do that. Here's the view report routine. You can see we have a parameter which specifies which report is to be viewed. But what you'll start to notice in here is that I'm not using a custom assembly that I've defined. I've got variables in my data division which are describing classes from the .NET framework. So I'm directly using system.windows.forms.form, its controls collection. I'm using a control called Microsoft Reporting WinForms Report Viewer, system.uri, and so on. And what's different about this demonstration is I didn't do any pre-preparation in Visual Studio. I'm just directly using classes that are available within the Microsoft framework. So when we look down in the code, you'll see there's a lot more code because I don't have that intermediate assembly that puts things together for me. I'm directly driving those classes. So I have code that creates and configures a Windows form, creates and configures the report viewer control, deals with URLs to the server report, specifies to the report viewer the report to execute, adds the report viewer to the Windows form, and in fact we're binding an event handler to the Windows form load event as well. And then we use show dialog to display the form. So the big difference here is I'm not using an assembly that I've defined in Visual Studio. I'm directly driving .NET Framework classes from my Synergy code. Okay, so let's look at what we had to do in GENNET to enable this sort of thing to happen, or at least using GENNET -S to ensure that this stuff happens in a reasonable way. If I switch to the other project in Workbench, we'll see that similar to the earlier example, we've got our .NET wrapper classes that are getting created. We've got our batch file that is generating our wrappers for the .NET assemblies that we want to use. The big difference here is that when we call GENNET, we're using GENNET -S, and you'll notice that I'm asking GENNET to create Synergy source file with this name, but I'm not directly specifying .NET assemblies to be processed. I'm actually specifying, in this case, 2 XML files that I want it to process, and these XML files in turn tell GENNET exactly the assemblies and the classes that we want to generate from. If we look at those XML files, the first one is very simple. The Graph Viewer class is very straightforward. It's simply saying from this directory and therefore from this .NET assembly, code generate from this specific class. That's not too much different to just naming this assembly directly on the GENNET command line. In fact, as it happens, this bar chart class is right now the only class in this assembly, so in fact the end result would be just the same. What's very different is what we do for the report viewer. You'll notice that when we look at the XML file that defines the requirements for the report viewer, it has several assemblies that are being used. Microsoft Report Viewer.WinForms, the MS Callide assembly, the system assembly, the system drawing assembly, and system.windows.forms. If you remember earlier, I mentioned that generating from system Windows forms alone generates over 80 megabytes of source code. If I were to add in these other 4 assemblies, we're into absolutely vast amounts of source code that will get generated. However, what's different about using GENNET -S with the XML file as the input is I don't have to anymore say I want to generate wrappers for this entire assembly. I can be very specific and tell GENNET these are the classes that I need to use within my application, and I can and essentially what's happening here is I'm listing the assemblies and the specific classes that I need to use in my code. GENNET will then simply process these classes. It will still process any dependencies, but only for these specific classes. So it's going to keep the amount of source code that gets generated and the size of those entities that get created at runtime down to a very reasonable level. And using GENNET-S really is a great approach when you're wanting to use framework classes. Certainly, if you generate from an entire .NET framework assembly, things very quickly become unmanageable. You'll also notice that what I'm doing here is I've got this one project called .NET Wrappers, and I'm using different use cases. So for different applications or different programs in my application, I'm specifying, well, for this program, these are the classes I need. For this program, these are the classes I need. And I just generate one set of wrappers that gets built into one library that my programs build against. So it also is a great way of simplifying the development environment as well. That's a summary of the GENNET-S feature, allowing you to be very specific about the classes that you generate using GENNET.